Hi everyone, today we're back for a new episode on Oxygen Not Included, and today we see the different elements that allow us to consume power. So the first thing you need in order to consume power is a wire. So here I've used a wire and I've connected all these hydrogen generators together, and also I've connected all these gas pumps together with that will consume the power produced by these hydrogen generators. And now if I unpause the game, we'll see what happens. We can already see that it turns red, and eventually we will see that, yeah, we can see here that we got some damage overloading. So we have damages here because the circuit overloaded, and therefore it received damage, and it's going to keep receiving damage until it completely breaks, and then you'll need the applicant to repair it. So why does this happen? Well, it happens because here we have a potential load of 1920 watt and the current load is 1200 watt. So both of them, so what is the current load and what is the potential load? The potential load is the maximum load that this wire can have. So here we connected machines that here it's all these machines are 240, 240, 240. So all of them together connected together. If they work all together at the same time, they will have a load of 1920 watt. So that is the potential load. At the time they're not all working, so that's why it's only needs to consume 1200 watt, and that is the current load. So now let's go back to the reason why this wire received damages. Now that we understand what the current load is and the potential load is, we can see that it has a current load of 1200 watt and it's red, and the reason it's red is because it's over the load that this type of wire can support. This type of wire can only support 1000 watt, and 1200 watt is over that number. So every time you have a current load that is over the supported load, you run into the risk of having that wire receiving damages, and that's basically what happened. So if we wanted to avoid having damages to this wire, to be sure, we would need to have machines connected to it that will never need to support more than 1000 watt. So we can either remove the current machines, or we need to use another type of wire in order to run all these machines on the same network. So here, if I remove some machines from that network, which is what I'm going to do now, we can see that the potential load has decreased. So if I unpause the game, we can see that now the potential load is 960 watt and the current load is 480 watt. So they're both below 1000 watt, and that way we can see it. By the way, the wire is now white, it's not red anymore. This network will not receive any damages anymore because the current load will always be below 1000 watt, which is the supported load for that type of wire. Another solution to solve that problem would be to use another type of wire. So if here I use the conductive wire, we can see that the max power is 2 kilowatt instead of 1 kilowatt. So it's basically twice as much. And if here I connect all these machines together, we should not have any problems. So we can see here that the potential load is 1920 and the current load is 960, and it varies of course, but we'll never have any problems if we have a potential load of 1920 because it's below 2000, and as long as it's below the supported load, it's be fine. But if now I start connecting these machines as well, we're gonna start to run into problem as well. We can see here it's already red and we have a potential load of 3120, and obviously the current load sometimes is going above the 2000 watts that is supported by that wire, and therefore we can see that we already have overload damage because of that. So in regards of the wires, so the normal wires and the conductive wires, there's also a small difference. That's this conductive wire will require refined metal, where this normal wire, simpler wire, will only require metal ore. So now you might be thinking, well, how can I do to run all my machines in my kernel? Because little by little I will have more and more machines in my kernel, and that's why we will need to use a heavy watt wire, just like here. This heavy watt wire can support up to 20 kilowatt, and there is another one that can support up to 50 kilowatt, and we need to use them with power transformers. So we have a large power transformer here and a normal power transformer. So there are two different types of power transformer. And what do these power transformers do? They limit the energy, the power that will be passed in the subnet. So what do I mean by that is that here, everything that will come out here will never be over 2000 watt. So that way we will be sure that this conductive wire is not going to overload. And if I connect it to only 1920 watt like here, so it's never gonna break. That one is slightly different. It's a normal power transformer. It's basically the same concept. It's going to limit the energy, the power that it will be passed from this heavy watt wire to that subnet wire, which can only support 1000 watt. And therefore, we will be sure that here there will not be more than 1 kilowatt passed to that subnet. And therefore, if you don't connect them, if you don't connect too many machines to that wire, it will not cause any issue. So yeah, just as a side note, these large power transformers can pass up to 4 kilojoule per second, but these wires can only support 2000 watts. So I'm not sure why it limits to 4 kilowatts, because you can only use 2 kilowatt. So little by little, you will have to connect more and more machines to your network as well. So this, you might think, yeah, that's not going to be enough anymore to have 20 kilowatt on that wire here, because here we're already almost at 3 kilowatt. Well, you have another wire that can support more. This other wire can support up to 50 kilowatt, so you can replace it just with 50 kilowatt. And basically, what is the difference between these two heavy watt wire? Well, that one has a bigger decor debuff, so you don't want to not place it too close to your duplicants, because the decor will be better on it. And the other one has still a debuff, but it's only -20, where the heavy watt wire is -25. The other difference is that this heavy watt wire uses different materials than the heavy watt conductive wire. So it uses less rare material. So here is copper ore, for example, or mercury, electrum, any kind of ore basically. But here it requires refined materials. So it requires like copper, lead, cobalt, or iron, and this kind of material. So these are the two main differences between heavy watt wire and heavy watt conductive wire. And if you reach 50 kilowatt for that heavy watt wire, or heavy watt conductive wire, that means that you will need to split your network into two, because unfortunately there is no wire that can support more than 50 kilowatt. Another problem you could encounter is if you want to cross wires and therefore networks. So here we can see that we have an horizontal wire that we want to connect, and a vertical one. So here, if I try to connect these two and keep them separately, we can see it's not going to be possible, because here if I connect the horizontal one as I just did and the vertical one that I'm doing now, we can see that it's going to form a single network of wire. So that's going to cause issues. So how can we do that? To solve that problem, we will need to use bridges. So there are two different types of bridges. There is the bridge for normal wire, and there is the bridge for conductive wire, which is a conductive wire bridge. So here I'm going to use the wire bridge because I've used simple wires, but this is exactly the same concept for conductive wire bridge. To keep these two networks completely separated, we just need to use that bridge, and that way we can see that this network is horizontally connected to itself, and we still have a free space in order to connect the other wire, the other network. So I'm just going to connect the other network like this, and we can see that now these two networks are separated. The normal wires can go through the wall, so if I use a normal wire and I just try to build one through a wall, we can see that it's not going to cause any issues and it's going to go through the wall. But that is not the case for the heavy watt wire. So if I use a heavy watt wire and I try to connect it through the wall, we can see that it cannot be connected. So this network is not going to be able to go through the wall, and we will not be able to use the power on the other side of the wall. So this is a problem. To solve that problem, we need to use an element, and this element is the heavy watt joint plate. So if I use a heavy watt joint plate and I just place it here on the wall, we can see that it's going to connect our two heavy watt wires on each side of the wall, and the power will be able to flow from one side to the other side of the wall. There are two types of heavy watt joint plates. There is the normal one that we've just seen, that is for the heavy watt wire, and there is the heavy watt conductive joint plate, which is for the heavy watt conductive wire. So basically this is the same concept. This is just that the heavy watt conductive joint plate is going to be used for heavy watt conductive wire, where the normal one is going to be used for the heavy watt wire. Let's now talk a little bit about the different batteries because they all have different leak rate. So let's start with the first one, which is a normal battery that you probably have access to it first. And this battery has a capacity of 10 kJ, but it will have a leak of 1 kJ per cycle. The second jumbo battery will have a capacity of 40 kJ, so which is quite a lot, but it also has a leak rate of 2 kJ per cycle, so this is twice as much as the previous one. And the smart battery only has 20 kilojoules of storage capacity, so this is half of the jumbo battery that we've seen previously, but it only has a leak rate of 0.4 kilojoule per cycle, so this is 5 times less than the jumbo battery. So in terms of waste, the smart battery is the best, and it's not also just the best because of its low leak rate per cycle, but it's also the best because you can enable or disable power productions based on the fact that the smart battery is full or empty.